In Chapter 14, we look at a method of reading in data from other sources. In Chapter 8, we talked about the in-file statement, and as I said at that time, the in-file statement has been around for a number of years and of course is very reliable. It's limited to different types of text files as we demonstrated in Chapter 8, comma delimited, tab delimited, etc. Common practice now is that we're looking at spreadsheets. We may have other statistical software, and what we want to know is can some of those data sets that are these tables created in columns that we're accustomed so far to seeing in our data step, can those be read in from another source? And very popularly, such as Microsoft Excel, there may be some other statistical software that generates some kind of a permanent SAS data set, such as we saw that SAS does. And so can SAS read those? And the answer to both of those questions is yes. Yes, it can read an Excel file. Yes, it can read things from other statistical software. So we're going to do some demonstrations here using Microsoft Excel. We're not limited to that, and I'll show you in the process uh, where those deviations or um, are we limited to Excel? No, and I'll show you in the process where some of the other options are for us to select software that created these tabular arrangements of our data. Now, everything we've done up to this point, well, almost everything, has been programming code or syntax. We've looked at the Explorer window and talked about view table and how to do a little bit of point and click operations, and of course when we submit a program and those sorts of things. But in terms of generating results or any SAS code, we've relied on the editor window and our ability to be able to write that code. Here we'll introduce an import wizard. This is a point and click product to read external data files, and the reason I encourage the import wizard is because there are some changes in syntax in the code for this, and I found it's just easier for us to use the import wizard, and I'll show you how we can recover the code. I have a very simple Excel spreadsheet that I call Data 1, and I've got it stored on a G drive in a folder with my name. And so I want to demonstrate then how I read that data set or get that data set into SAS. So let's move over to SAS. So when I'm in the editor window here, I can look at the file pull down menus, and I see here an import data, and that's where we want to go. We can have a look perhaps at some other windows and see if we still have Chapter 13 in there from our previous video. We still have that import option available, so we don't have to always be at the editor window. That's where I'm going to set it so we can focus on the import wizard. So if I go File and Import Data, now opens this point and click dialog within SAS, and so down at the bottom of our SAS screen we see an import wizard here, and it asks us what we want to, what's the source of our data. And so Microsoft Excel is listed here in various versions, and we can look at this arrow down here, look at all the different options we have. And so previously, where we used the in-file statement to read comma delimited files, tab delimited files, space delimited files, those are all options here as well, and we could click on any one of those. We have several different releases of Excel, Microsoft Access, SPSS is another popular statistical software. JMP is another SAS product, quite a bit different from what we're looking at. DBase files, Stata is another SAS software, so you can see all these different options in here that are not just SAS files but generated by other software. We're going to stick with the default up here, this Microsoft Excel file, and move along and go to next. In this window, we're asked, we can either browse to the file or we can enter it directly. So I know it's in my G drive in a folder with my name, and it's the Excel file data1.xls. If you go back for a moment, if we look at the textbook, this data1 file is this information in table 14.1 on page 236. So I've just created an Excel file, and I want to call your attention to a couple of things. In the X column, I have a missing value where I input a period. In the Y column, I have a period indicating a missing value, and then one of them I just left blank. And so let's see how SAS handles these missing values. That's important to know, as well as I've got very simply some character responses and some numeric responses. So we want to be attentive to how SAS sees this when we bring it into a SAS data set. So we can hit OK. It's on sheet 1. Now if you've renamed your sheet tabs, those will appear, and so we don't only have data on the single sheet, so it says on sheet 1. And then we can look at options. To use the data in the first row as the SAS variable name, and that's what I would encourage you to do, the same as I did when we covered in file. Convert numeric values to character in a mixed types column. So if you have both numbers and letters in the same column, that you'd want to check that box. And so these others are defaults. We haven't talked about date and time functions in here, so we're going to leave those defaults set. I'm not going to check this convert numeric values box at this time. So we'll move forward and then go to next. We want to create a library. So this is just a demonstration data set, so I'm just going to call it demo. So I'm just looking for, this is the library, and this is the name of the data set. So that's going to create the two-level SAS name. So at this point in the import wizard, I could finish, and it would read that data set in. And I'm going to choose next, however, because this process of clicking these buttons in this import wizard, it's writing SAS code in the background, and I want to recover that. And so when I say go to the next window, here it's telling me it's writing the proc import statement. So the import wizard is a procedure called proc import, and so that I want to be able to save that. And so let's put that in the same folder on the G drive. And we'll just call it an import demo.sas. And if I already have one there, you can check it, or if you don't have one, that's not going to hurt anything. And now then next, there is no next. You can either move back and change things if you wanted to change the name of your data set, or you can finish. So let's finish. Okay, in the editor window we didn't have anything, and so let's look at the log window. So in the log window, it tells me that work.demo dataset was created. It has 15 observations and 4 variables. So let's go to the work library. We can see this dataset demo here. These others are in here from chapter 13. So I'm just going to click on demo. Alright, so I can see those 15 observations, the observation numbers here in the first column. The A's and the B's, notice the column headers from my Excel file are now in the column headers here. The numeric values, the period came in as a missing value in both these places. The blank space is, there is a period there indicating a missing value. All of these entries in these columns X, Y, and Z are numeric, so notice that they are right justified. For treatment, these are character variables, and it's a much narrower column, but they are left justified when you have character data. And so then, just like before, if we're going to work anything with this data set here, if we're going to modify it, add any characters to it, we need to close this view table. Now I have this empty spot here, and so we want to locate the program then on the G drive as I've used it, and on whichever drive you're using as you work through. When I move to the File Explorer for my computer, I've got this import demo.sas program down here that's been written. I have some other SAS data sets already on this drive. Here's that data 1 Excel file that it wrote, and I'm also have some more information for chapter 14 in the same folder that we haven't accessed yet. So this was our initial data set. So here's a preview of it. And so then we also have this SAS program, and it's not giving us a preview, but we'll just need to open that in SAS. So we can come back to this editor, we can go to File and Open Program and select that program off of the G drive and put it here to see what SAS has generated for us. So when I look in this folder, I've got this one SAS program, import demo.sas, and that's the one I want, and open. So that series of selections I made in the import wizard generated this code. So a range, that was the sheet name. The get names, that refers to the values in the first row being the column headers. Mixed types, I didn't enable that. The scan text and the date and time formats, I just said accept the defaults there. It's looking at Excel. We're going to replace this data set. If we say it had run an earlier one, we have the data file here being indicated where things are being read from. So here it's proc import. This is our source along with the range information. What it generates is this demo data set. And so here we've written the 2-level SAS name to denote work.demo. Now it's kind of through trial and error. Then at this point, if you wanted to modify anything in this data set, so as I said, it's just very plain treatment X, Y, and Z. If we go back to the view table, you can look at the view and it tells me the column names. If I go to column labels, they're exactly the same. If you have longer multi-word headers in Excel, those will be viewable, those will import as labels, and we'll talk about those in the upcoming illustrations or demonstrations in this chapter. Okay, so there's no labels here now. It gives me a quick view of the data file. So in practice, one would have generally much larger data sets than this. So go ahead and we'll close view table. And so now then, I can save this program such as I did. I've called it import demo.sas, so that's now available to me, so that if I wish to write a program and just start my code here, proc means, proc univariate, any of the procedures we've talked about before, or any of the ones we're about to learn, we can do that all in the same program. Now then you can save this proc import code as part of the program, so that if you do things in multiple SAS sessions, that is, you close SAS, come back, and you open up a project folder, if you leave the import code in there, then you don't have to go through the import wizard again. So to me, that's a huge time-saving advantage. Now, one of the things then that I have found for the different types, even within Excel, older versions of Excel, these statements change. And so for other software products, these options or statements within proc import can look different. What's in this quotation for the sheet tab names, the punctuation there with the $sign, and if it's a multi-word sheet tab, I've just generally found that it's easier to go through the import wizard and recover the code and keep the code as part of my program. Now then, before the run statement, there's an additional statement we can put here. So from chapter 8, we can add an additional line here that's labeled, so long as it's punctuated correctly with a semicolon at the end, and we can label each one of the variables in the data set. So I don't have anything here. I just put in generic label text for each of these, but the label statement is something we can add, and in it, so if we go through and run this or submit this code again, we'd already had the demo set created up above it, but now it lists the import code. Previously with the import wizard, that was the only feedback we got, were these two lines when we run the wizard. When you run the code, you see all of that here. It says it was successfully created, so the other one has been overwritten. If I go to the demo data set, now then I've got those simple labels I put in here to demonstrate. That's the default view, is on label, and I can switch it back to name, so that if I want to call the information in that column in any future procedure, I need to use the variable name and not its label. Can you do any kind of new variable assignment here? So let's say we wanted to say, can I say create y squared by taking y and raising it to the second power? Will that generate a new column? All right. We know how to run to check things out. So the worst thing that can happen here is that we're going to make an error. So let's check it out. So I submit it. Now the import procedure alone doesn't generate any printed output. So it kind of flashed there. We have to check our log, and right off we see that there's an error. So it allows us to do labels, but it doesn't let us do a new variable assignment statement in the proc import code. So that if you wanted to do that, if you wanted to create something like this, you would have to write a new data step. So you could write data, and you could overwrite demo, and you could use the set command, bring in demo, and then add y2 to it. And then you could just do this part, submit it, look at the log. So now we have 5 variables. Previously we had 4 variables, so it did pick it up, it seems. Let's look. And so we have a y squared here, and where those 2 missing values for y occurred, I have missing values for y squared as well. So we can close this, and then you can any changes you make here, you can save these changes and open the program then in another setting. And so rather than going through the import wizard again, you can just run this import code. In Chapter 8 we talked about a file name statement, and we can still use a file name statement here as long as it occurs at any time before any proc import procedure. So this would work for the any kind of recovered SAS syntax for proc import. Specify your file ref. Again, remember your SAS naming conventions and the addition that it can only be 8 characters. Whereas what is it you want to read, and then you can just put the file ref here instead of the complete path. This is advantageous if you have multiple pages in the same Excel workbook, and so that you can pick then exactly which sheets you want, or maybe you want to look at all of them. So if you do have multiple sheets in an Excel file, you need an import procedure for each one of those, and that's what we're going to demonstrate next. You may recall from Chapter 11 in regression and correlation, where we worked with a beef data set, and we had information on the DMI and ADG, ribeye area, carcass weight, and back fat thickness for 56 steers. Well, in this particular setting, I have that same information that we had in that previous chapter. It's in an Excel file, and it's information from producer 1 who had 56 steers that we examined. I have a second sheet 2 in here. Sheet 2, I have similar variables. This time I have a sex variable of the animal. I have both heifers, denoted by H, and steers with an S. Same variables, different order. I've got spacing in here. And then I have also producer 3. Producer 3, the headings are similar to producer 2, but I've got some special characters here in the headers, and so the header names are not all the same. So that's not a particular problem for me, and so I can get the import wizard to read in, say, any one of these sheets, and then copy and paste the import code, or just run the import wizard 3 times to import each of these 3 sheets. So the choice is mine. So I tend to do it once with the wizard and then copy it and modify that code for the remaining sheets. You can choose whatever works the best for you. So in the book I have the data here with a slightly different name. I've got the word import in here, Chapter 14 import data, producer 1. So I created the 2-level SAS name, and that's going to be the sheet name here. So that 1 indicating the producer. producer 2. Now notice then I've just used file name beef to recognize this Excel file. Within each block of procedure code, I indicate the sheet so I can identify specifically which producer. Producer 2, I didn't get a sheet name on that, it's just the default sheet 2. So you notice just kind of the single quotes inside the double quotes when there's multiple words up here. And then down here for producer 3, still recognize that file ref beef, and I'm looking at producer 3 here, and I import things the same way. So I can do all this to bring in all those 3 sheets and have information for producers 1, 2, and 3 as my temporary SAS data sets. In the editor, then I have my program that also appears in the book, and scroll up one line here. I have that file reference beef. My file name here is a little different than the book in the file name in the book. The word import's not here, but you can see the rest of everything matches up here, and so you can just highlight the procedures you need, submit those. Now notice that work library was open over here, and so we see things happening over here. Producers 1, 2, and 3 now have data sets over here. Let's look at the log file or log window. So it tells me bottom up producer 3 data set. Here I have 101 observations, 6 variables, 171 observations and 6 variables, 56 observations with only 5 variables. Okay, I don't see any indication of errors. I can look at the Excel files to see how their line numbers and to see that the 56, 177, and 101 correspond to the number of lines of data in those files. I can open any one of these and have a look. We've seen producer 1 here. Let's look at producer 2. So backfat was 2 words there. What is that? That's the column name. What's the column label? Was the 2 words backfat, and then whenever I look at the column name, there's an underscore where that space is in order for it to adhere to SAS naming conventions. If I look at producer 3, those special characters, the parenthesis around the pound abbreviation here, are both now underscores. ADG also had parenthesis around it. I had carcass weight. Here I have 2 or 3 underscores, not clear which. Ribeye area and back fat then are adhere to SAS naming conventions, and so these are the column names or the variable names. The labels are the special characters. So over here it was carcass weight, comma, space, and then the pound sign or hashtag, again, whatever age dependent name you call that. So I've got 2 different view tables open. If I want to do much more with this, I'm going to need to close those 2 data sets. I use those for confirming the number of observations and the names and number of the variables. Now when I looked at producers 2 and 3, they had an extra variable in there, a 6th variable for sex of the animal, heifers and steers, and producer 1 doesn't have that. Remember, in the context in which we were initially introduced to this particular data, it was given as there was a random sample of 56 steers from this producer back in Chapter 11. So these are all steers. So if I'm going to combine these together, I need to do a couple of things. I need to be able to track the producer. So I'm going to introduce a producer variable, and then as well for producer 1, I'm going to introduce the variable sex that is going to be set to S or steer for every observation. So we can do that in the syntax. So we have producer 1 and data prod 1, and we introduce a new variable that we just set the value of producer equal to 1 for every observation. We set all observations from this producers were steers. So that's my comment here. So I have capital S and quotation marks, and then I can label these and give them better looking labels than what we had in the Excel file where we spell things out. Same way for data in producer 2, I just need to add the producer name. I want to keep the same variable names from producer 1 to 2 to 3. So instead of back underscore fat, I want to use the rename statement. This was another chapter 8 statement, so if you want to go back and reference that, it's rename old name equals new name. Likewise for producer 3, the DMI and the ADGs as well as carcass weight, I need to rename those. Now, how many underscores were here? I think we determined there were 3. Sometimes that's hard to tell, and it's just trial and error that you do that. And so if I would have typed carcass weight with 2 underscores, it'd say there is no such variable. So then you try it with 3. Then once I get all of these with the same variable names in them, then I can create a set I'll call beef 3 for 3 producers, and I can set those together, producers 1, 2, and 3. The order of the variables will be determined by producer 1 since it's listed first. So let's go ahead and run this or submit this code. Beef 3 over here, I don't have anything new because I just have overwritten producer 1, producer 2, and producer 3. So now then I've got those better labels here at the top. I have the information for producer and sex. I went ahead and put those in proper case or title case, so I don't have to worry about using a label on those. And so that all my producer 1 information is at the top, and I can scroll down, go to producer 2. Notice there are several missing values there, so if you encounter that, you go back to the Excel file and confirm that. Just don't assume that's the case. And then I keep going and I'm into producer 3, and so when I see missing values, I want to investigate to make sure I've done that correctly. Now, for this particular beef 3 data set, this is bigger than most of the other things that we've looked at in this book. Those data sets have all been quite small. This one ends up with over 300 observations, so doing a proc print is probably not a good idea here or not necessary, so that's one of the reasons we look at view table. If you don't like the view table, you can do proc print. It's a temporary thing. You can put the print code in, proc print code in, run it, so you can have a look at how does this data look if you don't like the appearance of view table. Just remember that the proc print statement has a label option that you can you put in there so that you can have the column headers be the labels or they can be the variable names. Either one of those will work. So just as an aside here, on the import procedures, you can stack up as many as you like. I think my record in working on a project was that I had 28 import procedures in one program. That's all I let that program do, is I just set up several import procedures to read the data in from Excel. When you have that many data sets, being able to convert those to permanent SAS data sets then is certainly an attractive feature, because if it takes a long time for you to submit the import procedures to create your data set, you don't want to have to repeat that every time. So the purpose of SAS libraries and permanent SAS data sets becomes very useful to us. So instead of going things in the work library here, then you can identify a particular library name and you can put the permanent SAS data set in that folder. It does not have to be in the same folder as the source or of the data, which was the Excel file. It could be, but it doesn't have to be. And so then it makes sense then for us to create a new permanent SAS data set once we get everything created. Very recently I had another opportunity to work on a proc import, and it was only one proc import, but it had over 500,000 observations and took nearly an hour just for the proc import procedure to run. Therefore, once I ran the proc import, I had a data step in there and we made sure it was okay. I ran that and got it corrected, and as soon as we got it in correctly, then we made it a permanent SAS data set. So that's an hour we did not have to repeat every SAS session. Like the import wizard, there is an export wizard, and you likely saw that on the pull down menu for file when we did file import data. The option on the menu just below import data was export data. That means there is an export wizard. And so then we can do the same thing with the export wizard that we have done with the import wizard. We can let the wizard write the code for us the first time, and if it's something we're going to do repeatedly, we can recover the code. So here I didn't exactly call the previous actions. I didn't identify which one was objective 14.1, but so we're into 14.2. And so if I want to compute the means of each of the variables in these in this combined beef data set, and so that I'm looking for the default statistics for each producer and sex of the animal. We'll recover these in a SAS data set called beef3 means. We want to suppress the printing of the procedure results, or pardon me, suppress the printing of the procedure results and export these to a fourth sheet in our Excel file that would have this information. So here I have, we can sort beef3. It's in a temporary data set. The no print option was available on both proc univariate and proc means, and so I didn't select any statistics. I can say these are the 5 variables I want analyzed by producer and sex, so I have to sort them by producer and sex and then output them to a data set called beef3 means, and then we'll look at the export wizard. So if I take this code and drop it into SAS, and we'll look at the export wizard from there. So here in SAS, I take the beef3 dataset that was just created in the work library, and I can highlight the rest of this program and submit it. Always look at the log here. Okay, now I suppress the printing for the means procedure. I didn't have the no print on here like I do in the book, so it did print, so my apologies. I did a proc print on the data set. Let me go ahead and show you why here. If you have a number of combinations here, producer 1 and each sex, remember producer 1 only had steers, so that we don't have the second part of that for heifers. Sometimes those by statements, there can be several combinations, and so the means output can just kind of go on forever, so that's a good reason to use the no print option. I did the proc print on the beef3 means just so we could see kind of what's going into that data set. So it's got all the observations, and it's telling me the statistics it's outputting are sample size, min, max, mean, standard deviation for each producer sex combination. So I had 46 observations here, 84 heifers in producer 2, 87 steers, 31 heifers for producer 3, and 70 steers. And then the summary statistics as they're defined by this stat column for each of the 5 variables. And pardon the incorrect objective number. Now once I have this summary data set in beef3 means, I can use the export wizard to send it to a new Excel file or change that either a new file or put it into the existing file with a different sheet name. So let's go over here, File, Export Data. We want to export not beef3 but the beef3 means as an Excel file. We still have all these other software options like we did when we did the import. The workbook, what's the name of the file that we want? We want it on that in my G drive in the folder with my name. And we had chapter 14 data.xls xlsx and OK. Assign a name to the exported table of data. That will be the producer means. We can move to the next, or we can finish. I'm going to select next, and I want then in that same folder we'll have an export data.sas not very creative. We could have export beef, etc. And then we can connect or click finish. And then when I open the Chapter 14 data file, I have producers 1, sheet 2, producer 3, and then I have producer 3 means. And there, activate this, so that name I gave it became the tab, and it put that underscore in it, and then it listed all the information that we saw over here on the right and kind of behind here in the results view. All that's been recovered as a data set. So I can also look at the code for that generated this. So we can click File and Open Program, and we can click on Export Data here and open it. And this is the program that ran that generated that. So if I need this code and I need to put it at the bottom of another program, I can do that. So I can copy and paste this into another program where all of these results are generated, and then that proc export becomes automatic whenever I rerun that program. So say for instance you have modifications in your data set here, then you could rerun the entire program where you have all of the import procedures, your analysis procedures, and then lastly your proc export, and so that you can update everything as your data files change or are updated. Very cool tools, both of these, very useful tools. I hope you find them so.